Hello friends, welcome back to my another episode on Databricks. So till now we were doing some kind of a batch processing using Databricks, and I'm just shifting the gear for some time to go through streaming, right? So streaming is one of the important topic that we could see in this current world, right? We have a lot of streaming device, and we should be able to capture the data, process it, and generate the dashboard or report out of the result. So let's go through the basic thing of what exactly is streaming. So till now we processed very large finite volume of data as a batch and transform the data, load that data into final layer to generate the dashboard. But streaming data is a continuous data coming into the data lake or your system, and we need to process the continuous stream of data to come up with some kind of dashboard. So as a definition, streaming is the continuous process of endless stream of data. So when I say endless stream of data, we should understand what exactly it is. So I can explain that better by providing some kind of example, right? Um, think about your credit card. So when you go to any shops like a Target, Walmart, any place or any other retailer shop or any other merchandise, you will be swiping your credit card in the point of sale system, right? So what bank has to do is it has to capture every details of the credit card usage. Why it is required? Because that helps the bank to identify the user who used the credit card is the right owner. So to capture that, they have multiple method, right? They can understand the behavior of the user, what are the different items they are purchasing, where exactly it is located, which zip code, and what are the items they frequently buys, what age appropriate um, items they are buying. So multiple things that they can gather, but this is one method they capture the fraud activities also, right? In order to capture the fraud activity, then the bank has to find out this transaction immediately. As soon as you swipe, that data should go to their server, then analyze it, check the behavior based on your past activities. How that happens? So the stream of data, as soon as you swipe the data that travel to your backend server, then it has to capture immediately, then do the analysis out of it, then give back the result back to the system. So swiping of data, those kind of record, it's a continuous, right? It will never stop. We cannot stop. It may not be the huge volume like batch processing how we are getting, because every second we will be getting the data and we are capturing it. We are not waiting for 1 hour, 2 hour, or more than that to capture a certain amount of data and do the processing. So as soon as we get the data, we process it. That is one kind of example that you can use it for the real-time streaming. And the second example I can think of is like this is one of the example. It is mentioned in Microsoft website. I think long back when I read the Microsoft website, it was there. For example, there are a lot of trucks, right? Those trucks are delivering the products to different retailer showroom. So there may be perishable food also. So if any perishable food items are there, then definitely there will be kind of a refrigerator or something. So every second or every minute, that system has to send details to the server, considering the temperature, of the refrigerator or any other systems, the what you can say is like it is the diagnostic details of that machine every time. So why it is required? So those details it can capture real time and find out any issues in that refrigerator in the truck. So what will happen if something happened into the refrigerator, right? That complete perishable items may spoiled, right? So we don't need to, we have to protect that. So the continuous stream of data, it goes to the system that analyze the condition, working condition of the system. And if they find any kind of malfunctions or any problems in the machine, then it can send out a message or email to the truck driver saying that your refrigerator is having some kind of issue. Then it also find out the location of the truck. It can always send the location to the server. Then the server on the backend side, we can determine what where exactly the repair showroom or where it can take the truck to. Then also it can send back the correct address to the truck driver, right? In order to achieve this one, we have to receive the seamless real-time data, right? So these are some of the example that you can think of it for processing real-time data. Demonstrating streaming, uh, I'm considering another website where it's a free website for basic data. So we can make use of stock data, right? The stock data is continuous, right? It always check what is the current price, open price, total price, then how fast it is moving the price, or it's reducing or going up, etc. So this is the website. They have the API. They provide the API, and I use the same API for our streaming exercise, right? So they have given all the API details. What are the columns that is available in the API? Then how we can access the data. What are the parameters that we need to provide, etc. Right? So just I took the copy of this API and started creating the streaming exercise, right? So if you go to the pricing, it is not everything is free, so you can go to pricing and check how much it costs you, right? So I'm just taking the basic details for this example, so it's free, so you can also do the same. And I'm giving you the address down in the video so we can go and use it. To receive the data from the website that I showed you and store it in a folder, right? I'm going to explain the file streaming concept here. So we'll accept the data from the website and store it as a file in our lake. Then we can process the data using these files, right? So in order to store the data, store the files, I created a new folder called Apple ticker. Let me go and check whether it is there. So dbutils.fs.ls, and let's keep it here. Just want to check whether the path is available. Oh, sorry. Okay, so we have the folder there. Also, I want to check any uh, files there because I was testing this one before the training. So let me check ticker files are there or not. Come on. Okay, so we have all the files here. So I don't need to execute this again, but I can show you the code where I received this files, right? So let's go and check. So initially what did I do is I just captured the date. um, let's go there and see what kind of data it is coming first, right? So let me capture this in a notebook and capture this date 2020-06-25. So replace this bracket. I'll explain what exactly it is. So first I want to show you the data, then we'll go there, right? So execute this. This is the key, API key provided by the website, right? And this is the date parameter that we need to provide. So every call we are going to get one particular date data. So if you look at the result set, we have total volume, then closing cost, sorry, closing value, opening value, and this is the high value that day. So we need only that much record, right? So we capture every day what was the Apple ticker value, opening, closing, then high value on that day, right? So you can see that the result set is a JSON format, and we have one array and it captures these values inside that, right? So the one thing we need to keep in mind, for any streaming data there should be a schema. In batch processing it's not the case, right? For the batch processing we have high volume of data and the Spark infer the schema using the high volume of data. But in this case, streaming data, um, we are we are just starting the data, just starting to get the data one by one. It is not like a huge volume of data, right? So it's always have to provide a schema for the incoming data. All right, so you understood the data. Now if you go to the site, right, you can see what kind of values it's coming in. So based on that you can set up the um, um, values, right? Data types. Cool. Now we'll go back here. You got the data. If you want, we can see um, what is the value here in that specific example. So let's get this spark dot df equal to spark dot read dot json and provide the path. So let me take this. Okay, so we received the value like this. So we have adjusted count, query count, requested ID. These are not relevant for us. For us, we are interested in this result, right? So if you look at here, the result is started with a bracket. It says that it's an array, and the JSON result is kept inside this array, right? And I'm not interested in result count and status, but ticker is important, right? I can pass any ticker value in the website, then based on the parameter it can retrieve the value. But in this case I'm just passing Apple ticker and received all the Apple files or Apple data, right? Now come down. This is how I received the data and store it in the file. Use a request method. I explained this one in my one of my previous video. So the date I just started from 200 days before, right? Then passing that value as a start date and end date. So this is the string, and this is how you can pass the parameter by opening and closing the curly bracket, then dot format and pass the parameter value. I opened this exception catch in case if it is failed, then it print out the message here.
right? So once you receive this response back from this website, I'm inserting the value here as a JSON format. Okay, so while inserting the files, I also want to make sure that I'm capturing the date. So for that, I'm passing this date value as a parameter that will append the uh, name of the file, right? And this is the method, this is the function I use to put the value and creating the file inside that folder. Once you execute this one, then you get all these files in your specified path, right? So if you look at here, you can see that all the date is appended along with the file name. Now this one is receiving the file. Then, as I mentioned before, the schema is very important in case of streaming data, right? So first we need to understand what kind of data is coming, and I provided the schema based on the result. We have adjusted count, query count, result, request ID, results. Though I'm not interested in these values, I have to capture it because the data is coming as all this field, right, including all this file. And if you look at this one, this schema, this is very important, right? This is like a um, JSON format. It for the first one, as I mentioned, it is an array, so we need to open it array type. In order to use array type, first we need to import all the types here. And if you're not sure what kind of type you need to import, then you can just create import star, all the types you can import it. So once then inside the struct type, you need to create struct field inside here again, because inside this array type we have multiple values, important values, right? Then close this bracket. So your type is ready, your schema is ready, all the required fields are added into this schema. Next is we are going to read schema, read the JSON from here and display, right? Let's see what's happening, what kind of results that we are getting it. Yeah. Now look at this table, right? We received all the values: adjusted count, query count, requested ID, result, result count, status, ticker, etc. So this is just normal reading, the batch reading. But now let's see how we are going to read streaming. For reading the data as a stream, the only change is here you need to give read stream instead of read, right? So you can use Spark read stream and option equal to max files per trigger. This will make sure that at a time you're reading only one file. Then provide the schema that we defined above. .json, provide the path. So if you look at here, I just given the base path, I didn't give the file name, right? So what it will do, it will read the data and keep it in the initial df. Then I'm just doing some kind of formatting, right? As you see in the result, it is came in an array and in a JSON format. So we need to read the data using JSON. It's some transformation we need to do. That also I explained in one of my previous video. I can paste the video link down. You can go back and check how I explained completely, like in-depth explanation I given in that video. So I'm just exploring the result. I imported explode a function here to show that one field is column. I imported call. Then I also want to understand the data inserted from which file. That's the reason I included input file name. And I'm adding another column, that is file name. How I'm giving the value for the file name using the input file name, right? So let's see what is the result set it is getting for expdf. So you can see that the streaming initialization started. Since we given display expdf, it start querying the result. I just change that plot option. Let me change that to table. Now we can see one by one it started streaming, and the first column is still in array, right? So let's cancel this now and uncomment the second option. Now I'm going to pull only this data from the file name. That's why I'm using substring here. Okay, now display this one instead of first data frame. Look at the rightmost column. We have date properly captured here, and the file name is separately decided. I don't need the exact file name. I just want to capture the date. That will be part of my dashboarding. So, and the ticker for this ticker, this date, this is the opening value, this is the closing value, etc. Right? Now let me cancel this again and uncomment call df and display call df here. So what is call df is doing? Call df again transforming the data frame that we captured in expdf1. It's selecting only required column from the JSON result column, right? So column C, alias name I'm giving, that's a closing, and call.o, that is open value, then call.v, that is volume, along with ticker and date. So let's stream again. Yeah, now you started getting very cleaned table, right? So think about like this: your first request, that the URL request is not closed. It's keep on calling the new file every time and pasting the file into this folder. This streaming will be continuous, right? You're not going to stop it. As soon as the file comes into that place, that data will be displaying here. So this will continue, right? Now you can create the dashboard using this particular data. So let's say if you want to debug and see whether your data frame is streaming or not, how you can find out. That's also an important thing, right? So we have another option using, uh, let's say this is our data frame, say dot is stream. So you can say that yes, it is streaming is true, right? So let's execute this again. It says true because we are displayed the displaying of streaming. We are not cancelled the streaming, right? The streaming is keep on going. We stop the display. That's why it says true. Now if you change this plot, I mean graph into line, let's see how it is going. What's happening? 1 second. Okay, so it was not there. The plot values were not there. That's why it was not displaying. So let me do one thing. I'll cancel this one and run again. Yep. Now you are able to see the graphs. So in this session, I want to show you how we can do the streaming dashboard using file streaming, right? And I'll come up with the more videos on streaming with the small videos that will help you to capture each part separately. If you have any questions, please feel free to comment below, and I can reply on top of that. Thank you for watching, and please provide your feedback. Thank you. If you would like to receive more such videos, please like and subscribe to my channel. Also, if you would like to connect with me, I have provided my details here, my email and LinkedIn. So thank you very much.